Hello, my name is Jake Davila, team lead of Kepler-452b. This is for the post-quantum cryptography of the Reconfigurable Space Computing Lab. We have team members also Patricia, Ryan, Sarah, and Benjamin. The main goal was to have the UAV communicate with the UGV through post-quantum cryptography, while they both have ladder lights communicating with one another for distance and color. However, there were some shortcomings with the UAV, such as the ESCs not making it work. So ended up getting new fly color ESCs, which the motors do spin, but we're just working on the thrusts, sadly, at the moment. The UGV also ended up going through some technical difficulties as well. However, the main point of the project was the cryptography, so Patricia will soon demonstrate on how that works right now.
For this project, I combined PQKyber, a post-quantum cryptographic algorithm, which is a KEM algorithm, with ASCON, a symmetric encryption algorithm. First, looking at the code, it's divided into two. We have Alice, the encryption side, and then Bob, the decryption side. Under each code, we have two sections. First, the key exchange and encapsulation, which is done by Kyber, and encryption of messages, which is done by ASCON, the ASCON algorithm. So this is all done using RabbitMQ, which enables me to send the public key, ciphertext, and then encryption and decryption messages. So how this works is Alice generates a key, a public key, which is sent to this queue where Bob is listening to. Bob picks the public key, uses it to generate a private key and a ciphertext. The ciphertext is then sent to this queue. Alice picks the ciphertext and generates her own private key. These two keys are then compared. If they're the same, then we move on to the second section, which is actual encryption of messages and encryption and decryption of messages. If the keys are different, then we get an error. One of the important things to note about Kyber is that it produces a 256-bit key, while the version of ASCON I used takes a 128-bit key and a 128-bit nonce. So what I did was I divided the 256-bit key into two. The first part was used as a ASCON key for encryption, and then the second portion was used as a nonce. Additionally, for this project, I'm running Alice locally while Bob is being deployed on a Kubernetes cluster. If we look at Alice and Bob, if I run Alice, I'll see that a public key will have a public key within this queue, and we can see that it's showing 1. That means the public key has been sent to that queue. Then we deploy Bob. As Bob is deployed, immediately we see that Alice now generates her secret key. If I look into what's going on with Bob as well, we can see that Bob's key and Alice's key are the same. So now we can move on to encryption and decryption of actual messages. So for that, I have a few images on my desktop, which I'm going to send to RabbitMQ as messages. Use Alice to encrypt, and then Bob will decrypt those images. So running, if I run the code to send those messages, immediately I see messages are being encrypted and decrypted. So once all of them are done, we'll see under decrypted messages, we see that these keep increasing. That means that we're decrypting all the messages, all the images that are coming through. Now, the reason why we're not seeing the images here is because since they're JPEG, we need a way to view them. And the best way is for us to download them and then view them maybe in a file. So the way I'm doing that is I'm downloading them from RabbitMQ and then saving them onto my local machine. So if I run the code to save those images, I can see that the images actually appearing here. And that shows that the code is working.